Hi, good afternoon. It's Gene from maverickstar Observatory. We're looking at active volcano in eruption stasis. Now, they're not one of the most pleasant of nature's natural forces on our planet, but they are equally very important. If you're in the study of geomechanics or geomagnetics, you're going to want to know that, on your planet, within the core, it is active. And one way we know that we still have an active core is by the erupting volcanoes. Now, over the last 3 years, we've been paying particularly more interest to volcanoes that are erupting for the specific reason is that they have reduced by 1/3 over just a short period of time. And for any geophysicist, it's going to be of interest because they're going to want to know why this activity is reducing in such a quantity. I'll just give you for instance of why it's important. Mars used to have regular active volcanic activity, and it was visible by the scars that have been left now on the terraform of Mars. The other thing is that Mars, as I've said many times in the videos, used to have also a magnetosphere, and perhaps the declining numbers of active volcanoes led to perhaps a solidification of the core in Mars, and then in turn a reduction of its magnetosphere. It's very important because there are little stages that lead to events, and I feel it's really interesting to pay attention right at this point in time, because we're not only going through a geomagnetic reversal, which is 500,000 years overdue, because on average a completed reversal would happen every 350,000 to 350,000 years on average. So when we start to see the declining numbers in active volcanoes, even though they are not particularly the best part of nature to observe, they are one of probably the most spectacular phenomena to observe. But when we start to see them decline, we have to ask the question, is something changing within the core of our Earth? We live in a real hostile environment out in space, and the risks are many. For instance, we do have a real risk of a major catastrophe being caused by impact craters, from meteorites entering our atmosphere, or large bodies entering our atmosphere and creating devastating, perhaps a wiping out of biodiversity across the range through an Ellie-like instance. So it's really important that we study the volcanic eruptions on our planet, for the fact it does tell us that we still have an active core, and if the numbers are dwindling, then I think we need to investigate why that is, and more so at the particular point at which we're at right now during this geomagnetic reversal. Something equally important to active volcanoes is a distant point in our future. Well, rightly not so distant, we're talking about 2.8 years away. And I've heard a lot of people in the comments section ask what the 40-degree mark is, and I've explained it quite a few times, and I really don't mind going over this as many times as we need to, so that everyone understands what it is we're talking about. This is a theoretical point over the northern hemisphere, which we are 2.8 years away. If the migrating North Pole continues on its current speed and course, we will hit that point in about 2.8 years. And why the 40-degree mark is significant is because, based on a few experiments that we conducted here and the study of magnetics, we find that when an eagle is encouraged to migrate 40 degrees, it begins to, once it gets closer to 40 degrees, it starts to wobble. And the reason why it's doing that is it's because it's leaving the strong field lines. Now, I believe the reason why we've been seeing a relatively slow migration up to this point is because the northern hemisphere, or the north dipole, or magnetic north pole, has been in the strong field lines. And I believe, based on those experiments, that when we get to that 40-degree mark, we leave the strong field lines. Now, on the basis of the experiment, what we saw is when it goes past the 40-degree mark, there is a rapid movement, and it transfers from 40 degrees north to 40 degrees south. And then if the pole was to continuously reverse, it would probably take another 100 years, like it has for us to get to the 40-degree mark at this point in time, or maybe in another 2.8 years time, to fix permanently in its position. So this is another reason why I always say, we haven't reached equilibrium yet, because we haven't got to the point of where we go into the weak field lines and the migration happens a lot quicker. But also, not only does the pole accelerate from that point according to this theory, what will also take place is, as you would expect, and anyone else studying geomagnetics would expect, is that the magnetosphere will considerably weaken at that point. Again, because of the data's not there, because of the last completed magnetic reversal was 480,000 years ago, we are in completely new territory. And there is something else, I have to, express here, and that is the fact that we cannot consider this geomagnetic reversal like any other one that the Earth has gone through, even though the only records we have are, based on what geological findings have showed us, such as, the Mid-Atlantic Ridge seafloor spreading gives us an indication that the Earth has gone through many reversals. But this is unlike any other, for the simple fact is it's delayed. On average, we used to have a reversal every 350,000 years, and this time it has gone an extra 500,000 or 500,000 years. So we are well overdue this magnetic reversal. It is, and I have to mention this, it is recorded that we have had excursions which have not lasted and not kept the new position of the pole. So we have had short magnetic reversals which are not considered permanent ones like we used to have, or the ones that we talk about at this point, but we have had those. And equally, I would have assumed that during these excursions, the poles migrated. They probably didn't complete a 180 degree reversal, or they may have, but there was something not supporting a full reversal in the core, and therefore it went back to its original positions. But one thing that would have happened during these periods of time would have been, again, a magnetosphere decline. And this is really what we're concerned about here. Not only are we in a time where we face new territory because this reversal is delayed by 500,000 years, but we also have unfortunately coincided with something else, another anomaly, and it just makes matters much worse for us, because it creates the same problem. And of course what I'm talking about here is the geomagnetic not the reversals of the sun, but the actual solar minimum that we are in right now. And this is a period of time where solar activity has declined and has been continuously declining over the last 33 years, and as a result we have a weakened magnetosphere on our planet. So guys, the clock is very much ticking, and our governments around the world have pretty much left us in the dark with regards to the information on this anomaly. It's not just the grand solar minimum creating a situation where the heliosphere shrinks. It's not just the Earth's magnetosphere weakening at this point that we're in right now that allows all this cosmic radiation in. And we only hope that the reason for this delay of 500,000 years is nothing more than a little bump in the road, because if it is pointing towards a solidification of the core of the Earth, then we could see the last magnetic reversal the Earth experiences, and as a result of that the magnetosphere may not even come back up and shield us. We will be left with a situation where our atmosphere is stripped away by not only radiation coming from the sun, but also outside our solar system and from the rest of the universe and the galaxy that we're in. So, you know, that is the level of importance of this situation. And I believe that I'm the only observatory that is here, that is informing the public. And, you know, at the same time, it is a bit of a struggle. But even though, you know, the support has come from just a very small amount of people, we have achieved miracles, really. What you're looking at on the map is our stations that we have around the world. We have M1 in Canada, M2 in Arizona, we've got M4, I know it's not over China, but it is in China. M3 we lost in India, but we hope to get M3 back, but that will go to the epicenter of just below the Arctic Circle in Russia. And we have M5 and M6 on the east and west coast of Australia. All these people are not paid, they're doing it voluntary for us, and they invest their time for us, as well as, you know, their electricity that runs the equipment. I know it's not a very power consuming piece of equipment, but nevertheless, you know, I am very respectful. I know that there's a lot of the subscribers on YouTube that are very respectful for what efforts they've done for us to this point, but we are no by any means way finished. There is a lot of work to do, and as you know, there is a short period of time to do this in. We need to get one of our magnetometers and one of our muon detectors out to M8, Brazil, South America, and we also need to get M3 into Russia. And it's not easy, but we are always trying to do whatever we can. Like this week, you know, there was a little support given, allowed us to buy a green screen, and I think you will agree by this video things are starting to look a little bit more promising with regards to the viewability of these. You know, the content is improving, and in turn we hope that that will bring in more people to the topic, and they will become aware of what is going on and what is not being shared with these people around the world at this point in time by mainstream organisations. You know, I could mention two straight off, NASA and the European Space Agency, and, you know, with regards to those, there is very limited information, even though they have dedicated at least 3 spacecraft to the study of the geomagnetics of this Earth, and withheld at level 3 that information to us. You know, we can give them a good run for the money, and we have at a few points in time beat NASA and NOAA to the announcement of big changes that have took place with our Earth's magnetic field, and you know, that has led to them updating the world magnetic map, but they still make big mistakes, and we've pointed them out with the legend on the bottom of the maps not showing the correct dates. Simple things like this you would expect organisations that get public money to get right first time. But if it wasn't for, you know, me bringing it to the attention of some of you guys, and at least one of you heroes going then to NOAA and mentioning it about the legend, it wouldn't have got corrected as fast as it did. And, you know, that just gives us more credibility here at our observatory. Some people say, is it an observatory? Well, I guess it must be, because we've got stations now in, you know, pretty much all the important parts of the world, albeit two, and at a later date we will have those. We are an observatory in any case, because we have the TriMag system, the magnetosphere sensor here in the UK, and this is really the hub for all that information that comes from the rest of the world to the UK. You know, sometimes it's almost like you have to pinch yourself to realise that, you know, as a crowd-funded observatory, how far we've come. And, you know, it has been a lot of hard work, guys. Honestly, even this week has been and last week was very hectic for me, you know, getting my head around this new broadcasting software so I could improve the quality of these videos, because, you know, after being told time and time again something needs to be done about the audio, and, you know, you need to have it visually more interesting for people if you want to get their interest in this topic. So, you know, with that, I went out and invested the time again. And I will say this, these videos are going to continue to improve, The quality is going to continue to improve, and we haven't got the studio fully set up yet, and we're limping along with very poor lighting, but still I believe that what we're showing today is, and I think you would agree, probably 100 times better quality than what we've had for the last 2 years. And it's the same for the level of data now that we've got coming in. The quality of data that's coming in now from the different locations has also improved. But I have to stress this, and I know it is at this point in the video which people don't like to hear. You know, we are a public supported observatory. We do not receive any corporate funding here. The reason simply is because if we do, we start getting told. I've heard this happening on other channels on YouTube. Once you get into contracts, you have to abide by them. They seem to think that they own you, and that is not the case. This observatory is owned by you guys, and that's the way I want to keep it. We've come this far on our own. There's no reason why we can't take it much further, and like I say, I have to stress the importance. We've got little time to do it. If the theory of the 40-degree mark is anything to go by, we've got 2.8 years based on the current migrational speed of the magnetic North Pole currently. So, you know, I will mention the link down there, and I really hope that, you know, some people, you know, see it a little bit more rewarding now to support this observatory, not just for the extra effort that we're putting in, but for the need to keep going and getting more equipment out there, which is built here in the UK at this observatory site. You know, it's not just collecting data. You know, we're actually soldering these muon detectors together, you know, ordering in the components, building the muon detectors, building the magnetosphere sensors and magnetometers that go out into the field. So, you know, there's a lot of work that goes on. And not only that, we try and keep you informed on current events which we feel is relevant to you from time to time. So, you know, I'm hoping that you will support us from this point on, because I can't stress enough, you know, this is one of the worst points in time of the year for us at the observatory during the Christmas period, where the funding drops off, and even more so than ever, it is because of COVID-19 and the policies and implications and how it is affecting other people. But you know what, guys, I will say this: we are not out of the woods. You know, we are approaching a time where we are about to see perhaps the equilibrium, and it will be the worst point in time for us. If we can get more information on what we're observing, it might not just be a hopeless case for us. There could be, you know, places around this world which are more habitable than others, and at least you get that opportunity to know that firsthand. And more than that, you get your regular information on the topic of the geomagnetic reversal, which is being recorded by this observatory every 3 seconds at a resolution I believe no other observatory records on. I don't even believe Swarm mission records every 3 seconds at that resolution. So, you know, we are really packing a massive punch, even though we are the size of David compared to the giant Goliath. So there's a link down there. I hope you support us, and you know, I'll continue putting the work in and striving to get the equipment out there in the field so that we get more information back to you guys. That's the important thing. There's nothing else to say other than one thing. Guys, you have an amazing day. Take care of your loved ones, and I'll be back at some point this week with another update for you. As always, bye for now.